Hey y'all, today we're going to be looking at activity one. I'll be walking you through some of the ways that the periodic table is organized. So it's first important to know that everything on the periodic table is an element, which is a substance that can't be broken down further. It has its own unique chemical and physical properties, and they're categorized by those properties. All elements have a name and a symbol associated with them. It's important to know that an element is not necessarily the same thing as a chemical. Some people say that what's on the periodic table is chemicals, but like we could consider sodium chloride a chemical or water a chemical, but those things aren't on the periodic table. The things on the periodic table are pure elements. There are three types of elements that are grouped. We have metals, which have characteristics that we associate with metals. They're normally solid. Only mercury is a liquid at room temperature. They're typically shiny. They're malleable and ductile. Malleable is a word that means it can be hammered into sheets or foils. So if we think of tin foil or aluminum foil, and ductile means it can be drawn into wires. So think of like copper wire over here. Most metals can do that. Usually metals conduct heat and electricity. They'll often have high melting and boiling points, so they need to get really hot before they turn into like a liquid, from a solid to a liquid. And metal atoms usually form positively charged particles. We'll talk about this more in our next unit. Our next category, or before we get to that, here's some examples of common metals. Iron, lithium, potassium, even things like sodium are examples of metals that do fun things like interact with water, but all of these are examples of metals. The next most common group on the periodic table is our nonmetals, which are typically gases and solids. Bromine is a liquid at room temperature, but for the most part, they're gaseous and rarely solid. Nonmetals are brittle and can't be rolled into wires or hammered into sheets, so they are non-malleable and non-ductile. They're poor conductors of electricity and heat, and in many ways, they're the opposite of metals. There is a special group that's worth noting, the diatomic molecules, or the Hofbrinkel twins, as I'll often call them. All of these molecules, instead of appearing just alone as an atom, like a carbon might appear just as one carbon, these guys are all going to appear bonded to their neighbors. So H would be appeared bonded to another H. O would be appeared bonded to another O. And that's why when you hear people talk about the oxygen and that we breathe, they don't say we breathe O, they say we breathe O2, because oxygen appears in this diatomic group of the Hofbrinkel twins. The rarest group, or here's some examples: sulfur, carbon, phosphorus, bromine, iodine, nitrogen, oxygen, fluorine, chlorine are all examples of nonmetals. The rarest group is metalloids. Metalloids are metal-like substances. That suffix oid means similar to or like, but not exactly. So metalloids are like metals, but not quite. They are solid at room temperature. They have characteristics of both metals and nonmetals. So silicon, boron, arsenic, antimony, germanium are all examples of metalloids. From these categories, we break them down further into families, which are kind of specialized categories within them. And the most famous family is the noble gases. The noble gases are famous because they are our inert chemicals, which is a word. This word inert means non-reactive. These chemicals, these noble gases, are kind of famous because they're the only things that really don't want to react with other substances. Noble gases are called noble because they're kind of better than everything else, right? Or they think they are, because they don't need to react to be happy, as it were. All of the noble gases, as the name implies, are gases at room temperature. Helium, neon, argon, xenon, krypton are some examples. Then we get into how elements are organized, which is kind of a two-way street. The first is that elements are organized into groups or columns. So any column on the periodic table is called a group, and any row on the periodic table is called a period. And these groups and periods tell us certain characteristics about the element that we'll get into more in the next video on periodicity. But for now, we'll go through some of the most famous groups that we call families, like, again, the noble gases. So here we have all of our whole periodic table out here colored. And I would recommend coloring your periodic table just like this. In blue, so everything in blue here, all of these are our metals, everything in blue. And if you were to ask me generally where the metals exist on the periodic table, I would say they're like on the middle and on the left side of the periodic table. The next group we have, or the next category we have, is our nonmetals. Our nonmetals are all our guys here in orange, including hydrogen up here and down here. So these are kind of oddballs. Hydrogen is kind of an oddball in that it's over here. We'll talk more about why it's over there in the next unit, but mostly it just has to do with the fact that it has one proton, one valence electron. And then, of course, in yellow along this staircase, we have our metalloids. So we can see here that the metalloids do a good job of separating the metals from the nonmetals. Now, to get even more specific, we have some famous families. The first family that we've already talked about is our noble gases. You can find them in the 18th or the last column, the final group on the periodic table. And noble gases are special because they are inert. They don't really tend to react with other things. Another famous group that I'll point out here is this first group, the alkali metals. The alkali metals are a family that is famous for being very reactive. They are the most reactive metals. Next to the alkali metals is the alkaline earth metals, which is the second column. Oh, before I move on, it is worth noting hydrogen is not considered part of the alkali metals because it's not a metal. The second column, the alkaline earth metals, are soft metals that are important for biological function. We can see easily that alkali metals and alkaline earth metals are easy to get confused. I remember them because the alkali metals, that's a one-word name, so it's in group 1. The alkaline earth metals is a two-word name, so it's in group 2. The next big chunk of metals is all over this center block, okay? Everything within this center block, this kind of lowered block, is transition metals. And transition metals are special because they're not special. Most groups have a lot of categories that keep them together, but transition metals are kind of hard to predict. So we call them transition metals because they transition between the metals and the nonmetals. The next famous group we'll talk about is the halogens. The halogens is this group of nonmetals, and the halogens are famous for being the most reactive nonmetals. Again, we'll talk more about why they're so reactive in the next group, in the next video. But our halogens are our most reactive nonmetals, and they appear in the second to last or the 17th group. So understanding where these families live on the periodic table can help you navigate the periodic table easier. Something that I would expect you to be able to do is, given any element on the periodic table, like if I say cobalt, for example, you should be able to pick what group that lies in. The best group that I would call it, it's in group 9, and it is a part of the transition metal family. Cobalt is right here, okay? If I gave you nitrogen, you could tell me that that is a nonmetal. If I gave you fluorine, you could tell me that that is a halogen and a nonmetal. So all of these are going to be important skills for you to learn. Thanks.